Hello and welcome to another video. In this video we're going to be working on linked list cycle, and in the problem you're given the head of a linked list and you want to determine if the linked list has a cycle in it. And there's a cycle if there's some node in the list that can be reached continuously by following next pointer, so basically just a circle. And return true if there is a cycle, otherwise return false. So in this first one you can see there is a cycle, second one there is one as well, third one there's not. So there's kind of a few ways you could do this problem. One way is you can do some kind of modification to the inputs and then change it back. So like, let's say you just add, like, based on the constraints, you can just add some value to these. So if the constraint is like 10 to the 5th, you just add like 10 to the 7th or something, some big number to all of these as you go. And then if you hit a big number again, you can just return there's a cycle. But before you do that, you clean up all your variables. So any number that's like bigger than 10 to the 7th, you subtract. That's one way, but you'd have to modify inputs for that. Another way is kind of like a hacky solution as well. So if there's only 10 to the 4 nodes, you can basically just loop through this 10 to the 4 times, or until you are, so you just keep going to the next node until you either do it 10 to the 4 times or until you reach like an undefined node, right? So if there is no cycle, you'll just be out of bounds where you'll be on a null node. And if there isn't a cycle, you'll be out of bounds, because there's only 10 to the 4th node, so if you loop 10 to the 4 times, you'll just be out of bounds. Or if there's a cycle, you'll just keep looping back in a circle and not realize it. The third way, kind of the clever way, and kind of unintuitive if you haven't seen it, is called the tortoise and the hare slow and fast pointer. So essentially what you do is you initialize a slow and a fast pointer, and a slow pointer moves one node at a time, and the fast pointer moves 2 nodes at a time. And for any linked list with a cycle, basically what's going to happen is, since the fast pointer is moving faster, eventually the fast pointer will just loop around and hit the slow pointer. It might take a few iterations, but it'll basically happen. So we can take a look at that in this example here. So if we have like 3, 2, 0, 4, and this comes over here, this comes over here, this comes over here, and this loops around, we can take a look at that with like 2 pointers. So here's our 1 pointer, here's our 2nd pointer. So we'll say this first one's our fast pointer. So what's going to happen after 1 iteration, the fast pointer will move up twice, the slow pointer will move up once. Oops. Slow pointer will move once. Maybe we'll just have it a different color to make it easier to see as well. So slow pointer. Then after the 2nd iteration, the fast pointer will move twice again. So 1, 2, slow pointer will move over here. And then 1 more iteration, fast pointer will be over here, slow pointer will be over here. And then 1 more slow pointer will move over here, and the fast pointer will move over here as well. So they'll eventually collide if there's a cycle. So that's the solution we're going to code. Like I said, the other one is the hacky one, where you just loop the size of your constraint, and then you'll basically guaranteed to have that work. We can actually code that one up as well real quick. So we can just say, like, for I in range, what's the size of this node? The length of this is 10 to the 4th, so we could do like 10 to the 4th plus 2 or something, just to make sure like we go enough. We can just say, like, if head equals null or none, Python, we can just return there is no cycle, so false. Otherwise, head equals head.next. And then if you're able to make it through this loop, you just return true. So this should work. Let's see. So we got true, expected false. Oh, it's because I did 10 times 4. Okay. So now it should work. Yeah. That's one way, the hacky way. The other way is the slow and fast pointer, so let's do that one. So like I said, you just say slow equals head, fast equals head, and you just make your fast pointer move up 2 nodes at a time. If your fast pointer ever goes out of bounds, you don't have a cycle. And also, because your fast pointer is moving up 2 nodes at a time, you have to make sure fast.next is not null, otherwise you'll get a null pointer exception. So we can say, like, while fast.next, and you don't have to check for slow, because fast is always going to be ahead, so if there's no cycle, fast will just go out of bounds first. So slow equals slow.next, fast equals fast.next.next, and if they're equal, then there's a cycle. Otherwise, fast will just go out of bounds and you just return false here. see here. I guess we have to. Yeah, I guess, yeah, so fast can be out of bounds, so we have to check both, right? Yeah. Because, like, let's say we have, let's say our fast pointer's like over here. It'll go here, then here, and now we'll be out of bounds. So we're trying to access the next of a null node. So we have to check both. So and this should be good. And there we go. So as far as runtime, it's like all close to the same, so whatever. It's not a big deal. But yeah, so that's kind of like the tricky one. Not super easy to figure out if you haven't seen it before, but kind of clever. And you can use this for a lot of linked list problems to make sure, like, to get to like the halfway point of a linked list. This also works, right? If you're trying to get to the center, you just make your fast pointer move up twice, your slow pointer move up once. Then when your fast pointer is out of bounds, your slow pointer will be in the middle. You can slightly adjust it to be on like the left middle or the right middle and so on. So time here is ov(n), and space is ov1. And yeah, the other solution is also ov(n), or changing the variables would also be ov(n). So basically anything's ov(n), and you don't really have to make any more nodes or anything. So yeah, pretty easy one. So if you like this one, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.